All right. Thank you for joining at this next series of Hoots that we're doing here at Solo. And we're going to be talking about networking at the edge. And we're going to look at technologies like proxies, Ingress controllers, and API gateways. Go to YouTube and subscribe to the channel there for Hoot. Hoot is what we've been doing probably since the beginning of this year, January, where we explore interesting technology that we're either using or building tools for in the greater ecosystem, and not limited to that. But our interests thus far have been around service mesh and API gateways. In previous episodes, we looked at service mesh and did sort of an intro to service mesh. So starting in January, actually, if we come here, we can see the list of Hoots that we've done. Starting in January, we look at some of the new features in Istio. And then from there, we've had different introductions to Linkerd and console service mesh and AWS App Mesh. Then we looked at Kuma from the folks at Kong, as well as Mesh from the folks at Containus. And then the most recent episode that we did was choosing the right service mesh, looking at different dimensions along which you might make decisions about a service mesh. And that kind of wrapped up our introduction to service mesh series. And today we're kicking off with a new series called, as I said earlier, all about proxies, and we'll be looking at proxies and Ingress and API gateways. I highly recommend that you subscribe, by the way. So I am your speaker for today. My name is Christian. I am a CTO, field CTO at Solo, and I've been involved in helping companies build large-scale distributed systems and automation on top of cloud platforms for probably the last 5 years, and building on top of Kubernetes specifically the last 4 or 5 years, but building distributed systems probably for the last 10 to 15 years. I try to share some of the learnings and experiences that I have on my blog. I've written a few books on microservices and service mesh, and so I'm writing Istio in Action right now. Just recently updated to Istio 1.5, by the way. But my interest, as I said, has been in how do we connect our applications and what are some of the solutions that enable us to do that in a way that allows us to build our applications faster and make changes to them faster and do that safely. Because as we know, if we're exploring cloud technologies, that building on the cloud, building on a platform like Kubernetes, where we're building things as smaller services and trying to compose them at runtime, communicating over the network, and so forth, that ends up becoming pretty complex. And as we move to microservices and services style architectures, a lot of that complexity that didn't necessarily exist at the same degree in our monolithic systems, that complexity now moves between the services here. And the technologies that we looked at in the previous Hoots around service mesh help to solve some of those challenges. But we're going to take a step back now with this series. We're going to focus in on the proxies that you might end up using for a service mesh or for gateways, and understand some of the challenges around doing that. So I'll give you a quick heads up that we're not going to get too deep right now. We're going to kind of set the stage for the future sessions or episodes, and I'll show you that in a couple of slides here in a second, which ones we'll be covering, which of these proxies we'll be covering. But just to set the stage, let's understand what a proxy is. Proxy is a network component that sits between a caller of a service and the service itself. Now, these terms, the term service that I'm using here is used very, very ill-defined. So that service could be an API, that service could be a website, That service could be a message queue or anything. And what a proxy does is it sits in between the network path and can do things like enforce rules about the traffic. For example, limiting traffic. You might have a HTTP proxy in your enterprise through which all HTTP traffic goes, right? And you can apply policies about websites you're allowed to visit and so forth. And the proxy can enforce things like security. So when you connect to the outside, or you try to connect to the server, you want to verify or enforce that the traffic is encrypted, or that you're allowed to make those calls and so forth. So the proxy is pretty smart and tries to apply rules and control over the network traffic as it passes through. So this is generically what a proxy can do. Now there are specializations or variants of a proxy. You might have heard of a forward proxy. So it's a proxy that sits with the clients. And so this is an example of your internal HTTP proxy. It sits with the clients. All the clients talk through this proxy when they're trying to talk to a service or a server that lives outside of, away from the clients. And there might be multiple clients talking through this proxy. And as traffic leaves the clients, we're enforcing the policies and the routing and the security and so forth at that point. You may have heard of a reverse proxy, where a client doesn't know anything about the proxy. They think they're talking to the server or the service, and the traffic is still going through this proxy and being demultiplexed into the different services that might live in the backend. Now, more recently, with the talk and emergence of service mesh technology, you may have heard the term service proxy or sidecar proxy. And in this model, the nodes that are part of the mesh have their own proxy for both forwarding and reverse proxying. And in this model, as traffic leaves the client, we can enforce rules about routing and traffic control and get observability about what's happening at the client. But then as the traffic goes to the service or the server, and we also get those policy controls, rate limiting, authentication, authorizations at the server side as well. And then we can do interesting things like encrypt the traffic without the applications knowing and so forth. So when we talk about proxy, we're talking about these different generic patterns, and I'll show a little bit more specific detail about how we might apply that in a cloud application architecture. Now, one thing to also keep in mind is that these proxies tend to operate at different layers. So some of them operate very well at the layer 4, layer 3, layer 4, where they're interested in routing, for example, TCP traffic or UDP traffic, making connections and load balancing connections and so forth. Some of the proxies are really good at layer 7 control and routing. And at layer 7, we're not with connections or TCP or UDP packets. We're dealing with requests on things like HTTP or things like a messaging protocol like a Kafka or an AMQP or something. And so at the layer 7, there's a higher fidelity of understanding of what's happening on the network because it understands the requests that are going at the application layer. And that's where I've spent most of my interest is at the layer 7 networking, and some of the, especially when you get into cloud environments, some of the capabilities that you can introduce through the use of these proxies transparently to the application. So some proxies that you may have heard about or might even be using today that operate at layer 4 or layer 7 or both are things like NGINX, which has been around. Both NGINX and Envoy Proxy have been around for quite a long time. They're used as reverse proxies. They're used as forwarding proxies. They are less used as service proxies in a service mesh, though it doesn't mean it can't. And they're fairly hardened and very high performant and used to front a lot of web traffic or HTTP traffic as we see it today. Envoy Proxy, which came out of Lyft, fits both the forwarding and reverse proxying use cases, as well as the service-to-service proxy use case. And we start to see Envoy as a major component to a lot of the different service mesh implementations that are emerging. And then Trafic is also a more recent proxy that supports HTTP. It's kind of built originally to support Kubernetes and cloud dynamic workloads, and is written in Go in this case, and supports both HTTP and TCP-based traffic. So what we're going to do in the Hoot series that we cover for the forthcoming weeks is we're going to take a look at some of the gateways and proxies that are built on things like Trafic or things like Envoy or NGINX. So this is the tentative schedule with associated speakers, and we can look forward to talking about things like Ambassador, things like Kong as an API gateway, like Trafic and Contour, and ultimately Gloo. And from there, we can look at any others that might come up if people recommend, or we can kind of do a side-by-side comparison and wrap up at that point. So we'll end up seeing how things go, but this is tentatively what to expect. So we looked at a couple of patterns for what proxies do. Let's drill in, and it was very generic. Let's take a look a little bit closer in the context of solving some of the cloud native networking challenges in a cloud environment or something like Kubernetes. So one of the first problems that we'll face is when we deploy these applications into cloud environment, how do we get traffic into that environment? And how do we do basic things like routing that traffic to any of the services that might exist? How do we do basic things like securing? Maybe we want to encrypt the traffic as it comes in. So basic ingress is an important use case in our cloud architecture. We might want to extend that proxy to kind of shield away some of the details of the underlying deployment architecture. So in our cloud environment, maybe we are deploying into containers, maybe we are deploying into VMs or physical machines, and maybe into cloud functions as well. And so we might want to use a proxy as a point of ingress as well as indirection in terms of the deployment platform that's being used. We can also use proxies to define boundaries, not just along deployment, the actual deployment architecture or platforms like a Kubernetes, but also between the services that are being deployed into the platform itself. We can create boundaries around, let's say, certain groups of services that when they talk with each other, they talk at maybe a lower level protocol than how outside services might want to talk with them, right? So we want to provide that decoupling or that boundary to make more concrete the architecture, the application architecture. You might want to do this, for example, if you're exposing APIs. Maybe you're in financial services and there's a set of services that help you, I don't know, apply for a mortgage and walk through those steps. And, you might be a handful of services that you don't want to expose to every other caller or client. And so you want to put an API, you want to put a boundary around those groups of services. So that would be an example. Another example that you'll probably see, and we talked about with the service mesh examples in the previous episodes, is service-to-service traffic. So this is where that service proxy comes into play. When the traffic comes in through the boundary into the services that then start needing to communicate and call each other, the proxies that we might use there, the service proxies that we might use there, would solve the challenges around service discovery and maybe resilience aspects like timeouts and retries and circuit breaking and these types of things as services call each other within a call graph, within a boundary. And lastly, we're likely to see in any non-trivial deployments, proxies being used to facilitate the communication across boundaries, across platforms, across clouds. So more like gateways. So bridging together different networks. And for multi-cluster deployments or hybrid on-premises and public cloud deployments, we're likely to see both proxies acting as forwarding proxies or those acting as reverse proxies. Now, one thing to point out that I've tried to kind of try to make a point of when we start talking about these types of technologies is that we don't want to fall into the same approach that ended up proving to be limited. A lot of the things that we've done in the past, which is so if these proxies, if a proxy is so wonderful and these capabilities are so wonderful, then let's just force all of the traffic through one big black box, right? One big centralized proxy and mediation exchange. And in the past, this has, seemed attractive because now you have fewer deployments of a thing and you have operational and administrative control over the thing, and you are able to force processes and audit trails and so forth through a very simple set of rules and processes and maybe a single team. And as we've found that the more that you can distribute this and distribute your processes and give ownership to the folks that might need to interact with these proxies, the fewer bottlenecks we end up with, and the quicker we're able to go. And so that's just something that I want to point out, because one of the pet peeves that I have is replacing and modernizing people's infrastructure and their technology with newer technology that they end up doing the same thing with. And so I just want to point this out. All right, now let's take a look at some of the differences between what an ingress is and an API gateway is and how that relates to service mesh. So we covered service mesh, like I said, in the previous episodes. Now we're looking at the gateway or the proxies that form the foundation for the mesh, but how do these patterns differ from each other? Now, as I pointed out that with Ingress, what we're saying is we have a network, isolated potentially network, and a set of deployments, but we want a point of control for how traffic gets into those deployments. And we might be doing things like routing. We might be doing things like connection load balancing. We might be doing things like terminating TLS for encryption. And this ingress capability might operate at level 4 or level 7, like we looked at earlier. And is intended, like I said, just how do we get traffic into our deployments, and with some simple routing. Because what we don't want to do is, for every deployment, every service that needs access, so any of the, if we come back here, any of these services that have been deployed, for any of the clients that need to talk to them, we don't want to expose every single one of them out of our boundary. For a few different reasons: security reasons, for cost reasons. So for example, if maybe you're in AWS, and for every service you need to spin up an application load balancer or a network load balancer, that might end up becoming pretty expensive. So the more you can utilize those pieces as a way to get to your cluster, the lower the cost would be. Now, this is where things start to get a little confusing, because an API gateway also provides some of these same capabilities. But instead of saying one or the other, or the confusion becomes because of this overlap, we can say that an API gateway could be a superset of the capabilities of an Ingress. So what does an API gateway do then? So if Ingress allows traffic in, allows us to do some basic routing, allows us to do some security and so forth, what does API gateway do? Now, what an API gateway does is it not just shields the implementation details of the internal components, so the services that you've deployed. It exposes an API that is best suited for the clients. So right here, if we come back to Ingress, Ingress is just exposing the services as they exist inside of your cluster, right? So, and we just need a way for the traffic to get to those services. With an API gateway, we're not doing that. We're saying the services in the cluster, we're not going to expose them exactly like the way they're implemented. Maybe they're implemented with gRPC, and we want to expose them as REST services. Or maybe they're exposed as a REST service, but internally they're implemented by 3 different services, right? So the API gateway is a specific decoupling point to allow clients of your service to see a stable API, and the back-end components that implement the functionality for that API, those will evolve, those change, their APIs change, and so forth. API provides that abstraction, abstracts away the details of the implementation. But like I said, it does play the role as well of getting traffic into the cluster, so there is some overlap there. But in my mind, it's a superset of capabilities that is more targeted at the application layer in networking terms. So API gateways, they abstract away backend protocols, message shapes, and so forth. They abstract away the routing necessary to, let's say, compose a series of calls to get an appropriate message. They do things like transformation and so forth. They are intended to also solve edge capabilities that otherwise each service would need to implement. Things like authorizations, things like rate limiting, things like caching. And just like Ingress, API gateways provide a good point of routing control. So you can route very fine-grained requests, and as well as routing and traffic observability. So then that brings us to the question of, okay, API gateways and Ingress. API gateway could be a superset for when you need the capabilities of dealing with APIs. And maybe the technology overlaps. Right? So for example, you might use NGINX as an Ingress. You might use something like Kong as API gateway. Or you might use something like Envoy or maybe Istio's Ingress gateway as an Ingress, and maybe something like Solo Gloo as an API gateway. Now, like I said, the proxy implementations might overlap, and they further overlap with service mesh. Because in a service mesh, when we're talking about the service-to-service proxies, those might also be some of the same foundational pieces that are used as an ingress or an API gateway. But the service mesh proxy does something different. It doesn't, for example, like an API gateway, abstract away details of API implementations, for example. What it does is it gives the clients more smarts about the infrastructure. So it brings more detail to the clients about what's happening with services that we might need to talk to. So if service A needs to talk to B, B might be deployed on 3 different availability zones, and one zone could go down. And so the details of the infrastructure and the topology of the networks is something that's important for the client who wants to call the service to know. And that's exactly what the proxy is doing on behalf of the client. So it is part of the application, this service proxy, it's implementation detail. It runs out of process of the application. So you can see on the right-hand side an example of a service mesh where a service implementation lives alongside its sidecar proxy. And as I said, exposes details to the applications about how to call other services. Also brings things like security, observability, and so forth. So a service mesh proxy or the service proxy and an API gateway can use the same proxy as we've established, but for different purposes. In a service mesh, we're talking, service to service, point to point, and the service proxy needs control over routing, control over traffic encryption, observability, these types of things. But so does an ingress, right? So does the edge. The edge needs that as well. But at the edge, we need to solve different challenges than we might inside the service mesh or inside the, what a service proxy is built for. We might have more sophisticated security and identity verification mechanisms around maybe JOT or using something like OIDC or various protocols for establishing identity. Some that you wouldn't need in a service mesh. You could be doing things like web application firewalling. For example, in an API gateway, message transformation is really important. You might have backward compatible security protocols that you need to implement at the edge and so forth. So there is a difference in purpose for Ingress, API gateway, and service mesh service proxy. There's a difference in implementation and features that you might need at one particular part or the other. And they also work fairly well complementary. I've gone into very deep detail on all of these topics, and I encourage you to check that out. On the first one, API gateways are going through an identity crisis. We look at Ingress and API gateways and service mesh. But then on the article that I wrote, Do I Need an API Gateway If I Use a Service Mesh? We look at very detailed side-by-side juxtaposition of them, as well as how they work very well in a complementary fashion. So I encourage you to stay tuned to our series here, giving a little sneak peek. We've talked about this on other channels, but WebAssembly is shaking up the capabilities of the data plane. We'll see that through the Envoy proxy currently, but it's not limited to Envoy and some of the exciting work that we're doing here at Solo. Let me come back here and show you this. So coming up In 2 weeks, we'll be talking about Ambassador. We'll be talking in a few more weeks after that, Kong. So both of those API gateways, Trafic and Contour and Gloo after that. And we're open to suggestions from the community if we want to add more. And then we can wrap it up with a kind of comparison of the handful that we end up talking about. I just want to say thank you for joining. This was just a level set and overview of our new series all about proxies and API gateways and Ingress. Go check out the previous videos and previous sessions that we've done on Service Mesh, and go to the Solo YouTube channel and sign up for the forthcoming episodes. All right, thank you so much.
Hey, Christian, there's a couple of questions if you want to just take a look.
I don't have them up. Do you want to?
Yeah, one is.
Can you Slack them to me, or?
Yeah, so I can just read them off to you.
Okay.
One is an example for a client with proxy.
For a what?
He's asking if there's an example for client with proxy.
Client with proxy.
Yes, Krishna, could you, if you're still on, could you expand on your question? And then there's another one here, says, does someone have a newer container image of Envoy Wasm?
So we have been building against the upstream. Where is it? Here. That's coming out of Envoy Wasm. We our current tooling builds against. I don't know. We can go look it up. But yeah, so either Gloo or Istio 1.5, we're building against the more recent versions of Envoy Wasm, if that's what the question was about.
Great. And you folks, you can always take the discussions into slack.solo.io if you have more questions or other things you'd like to discuss related to this topic.
So if I can off the cuff find exactly where that Envoy Wasm is. Somewhere in here. I'd have to dig. I'd have to dig a little bit, but I could find exact git commit. Hit me up on Slack on solo.io or slack.solo.io, and I can find the latest builds for you.
Awesome. Sounds good. Thanks, everybody, and we'll see you next time.
Thanks.